All right. Hello, everyone. So, welcome to today's video lecture. This is over molecular formula. So, yesterday um, we went through the information on how to calculate the empirical formula, right? Uh, and so today we're going to hit the molecular formula. So, what is a molecular formula? It's a formula that shows the actual number of atoms of each element in a molecular compound. So it's not reduced or anything. The empirical formula, remember, is the lowest whole number ratio. The molecular formula shows everything. It's not reduced. So, for example, with glucose, kind of like I was showing you yesterday, the molecular formula of glucose is C6H12O6. The empirical formula of glucose would be CH2O. Right? Now, sometimes the molecular and empirical are the same. For example, water, H2O. That is the molecular formula. It's also the empirical because it's reduced as much as it can be. Okay. All right. So what we're doing today is finding the molecular formula, figuring this out. How do we do that? Well, the first thing is we need the empirical formula. If the empirical formula isn't given, you need to figure it out using the empirical formula steps. So if you don't have an empirical formula, you do what we did yesterday to figure out the empirical formula first. Okay. Once you get the empirical formula, even if it's given to you or you figure it out, then you calculate the mass of the empirical formula. Now, on these notes, I've already got some of this written in here. So this is the mass of the empirical formula, just like we were doing the molar mass. Okay, so calculate that. Then we divide the molecular or molar mass, same thing, the one given in the problem. They have to give this to you. Okay, so let me highlight that just so people. The molecular molar mass will be given to you in the problem. And you will divide that by the empirical formula mass, the one that you calculated. So the empirical formula mass is what you calculated. This gets you the multiplier, what I call the multiplier. Excuse me. If the multiplier is not a whole number or very close, you probably did something wrong in your previous steps. Okay, if it's like really close, you would round it. But like in general, like there's no like, if it's 2.5, there's no multiplying to get a whole number, whatever here. You did something wrong. Okay, so we're using this example still, the NO2. Let's say they give us a molecular mass of 92 grams per mole. So they're giving us this. That's our molecular mass. So we put that up here. Okay. And we calculated our empirical formula mass here. Okay. This gets us our multiplier, which is 2. Okay. Now, what do we do with our multiplier? Well, the reason I call it the multiplier is because we multiply the number of atoms for each element in the empirical formula by the multiplier number to calculate the number of atoms of each element in the molecular formula. Okay, it sounds a little confusing, but it's actually really simple. You look at the empirical formula. So we've got NO2, right? So number of atoms, and we've got 1. Oxygen, we have 2. Times the multiplier. So times 2. This is the number of atoms of each element in the molecular formula. So now we just write the molecular formula. N2O4. That's your answer. Okay. All right. Let's do another practice one of these just so you can kind of see it done. So on the second page of the notes, we have this practice thing here, and I'll kind of go back and forth between the two so you can see the steps. But if the empirical formula for mercury 1 chloride is found to be HgCl. So this is the empirical formula. The molar or molecular mass is found to be 472.08 grams per mole. What is the molecular formula? So the first thing is we need the empirical formula. If we don't have it, we have to figure it out using the steps we did yesterday. But we have it. We have it here. Okay. Second thing, calculate the mass of the empirical formula. So we've got HgCl, right? Cl1 is 35.5. I know that one off the top of my head. Hg is, look at it on the periodic table. So obviously it's 1 times, where's mercury? Okay, here it is. So that's, if we look at that, Hg is 200.59, so 200.6. Okay. So remember, we're taking all of our masses off the periodic table to 1 decimal. So it's 200.6. Add them together. We get 236.1. This is the empirical formula. Oops. This is the empirical formula mass. Okay. All right. Next step. Divide the molar mass given to you in the problem by the empirical formula mass. So the molar mass given to us here, so it's molar mass divided by empirical formula mass. So our molar mass, 472.08, divided by 236.1. Okay. This comes out to be this. So as you can see, this is like super, super close to 2. So that's okay to round, but we're not going to round something like 1.6. Okay, that's too far. Like that means you did something wrong. These numbers, when they come out, they should be either a whole number or very, very close. So that is going to be 2. And somebody asked me once, like they said, are all the multipliers 2? No, all the multipliers are not always 2. It's just the 2 examples I have are 2 so far, but they're not always 2. All right. So what's the molecular formula? So we take the empirical formula mass, Hg, Cl, right? And 1 times 2 is 2 for Hg. Chlorine, 1 times 2 is 2. So our molecular formula is Hg2 Cl2. Okay. All right. That's what do you need to show? What do you need to show in terms of work? You need to show for sure this show that part, and so obviously you have to show the answer. You do not need to show this multiplying. Okay. This part here, calculating the empirical formula mass, I'll make this part optional. I'm not going to circle it, you guys can see it. I'm going to make this, showing this work, optional. You have to do it, obviously. Showing that work can be optional. But just so you guys know, like on quizzes and tests and stuff, and even some homework, if I'm counting multiple points, I will count this as a point. So like, I will look at the number you have under here, and if the number's wrong, that's a point off. And then showing this, the dividing molar mass by empirical formula mass is another point, like a separate point. So just so you know that. All right. Okay, if you got questions, let me know. Otherwise, good luck on the homework.